Hi everyone, my name is Mohammed and I'm glad to be here presenting our work in video summarization. Let's start by dissecting the title of this paper. Video summarization is taking a long video and then extracting short snippets that are the most representative of that video. Multi-stream that mean that we have multiple views that are independently recorded. Then dynamic means that the views are intermittently overlap their fields of vision. Our task is to identify the important events across all the footage, and then select the most representative view or views for each of those events. This is a generalized problem setting. However, summarization problem is already hard. Generalization does not make it any easier. If anything, it makes it even more prohibitive to solve. Why did we formulate it this way? In fact, this setting presents itself in several real-life scenarios that need technological intervention. For example, sports events are recorded by dynamically moving cameras. The highlights that you see on YouTube are from many different cameras. Concerts or social events are recorded by too many smartphones, not to mention the multiple professional camera people. And finally, an example that touches our life in the US here is the rising claims of police misconduct that led to a proliferation of body camera recordings. Manually going through 10 to 12-hour shifts, 2 to 5 members of police patrols, it's just virtually impossible to be done by a human. However, it is crucial to thoroughly inspect the key details. Our formulation provides a guiding index for the supervision authorities to make sure that the copious amounts of data is properly analyzed and not overlooked. Since we were the first to add this problem, we started by collecting a data set for this generalized formulation. This had 41 sequences, 33 views, 6 scenarios, 30 FPS, 15 hours of collected footage. The second step is creating labels for this data set, but the most important thing is that they are reliable. For that, we developed a method that is called annotating in stages, and that considers each view independently, then interview dependencies. This helped us get a consensus F1 score of from 0.24 without our method to about 0.83, which is a significant improvement that leads to reliable labels. Now, using the data, using the labels, we developed our approach. And we started by considering a common statistical process that used in other video summarization methods called the deterministic point process. And it is a statistical method that used to select a diverse subset from a large ground set with a constraint on the quality and feature representation. What we started with is mathematically generalizing this formulation to include multiple ground sets rather than a single one. Then we used our multi-DPP to select diverse time steps. And we also used cross-entropy to select representative view or views at each of those time steps. The beauty of this framework that it allows us to build a summarization model with and without labels, thus enabling both supervised and unsupervised training, depending on the data that you have. This is what a holistic summary looks like. The algorithm selects all the events that were interesting regardless of the view. Then for each event, select the most representative view or views. Finally, quantitative evaluation, including multi-stream dynamic multi-ego benchmarking, as well as multi-stream static standard benchmarking in 3 different data sets in both methods. Our models, both the supervised and the unsupervised, trained, outperforming the baselines, showing a clear advantage over the state of the art. That's all I have. Thank you very much for the attention. Enjoy the rest of the